All right, this is video number 2 showing you how to use eigenvalues and eigenvectors to find the solution to a system of differential equations. So I've got kind of the step-by-step process listed here, and I'm going to try to go through this one a little bit quicker than the previous one. Here's our matrix A. One thing I want to say is that we want to find the determinant of A minus lambda I. So I'm going to introduce some new notation. If I had a matrix B, and I wanted to talk about the determinant of B, one notation that we commonly use is what looks like absolute value bars around the B. And that is a standard notation for saying the determinant of that vector B. So here I can write what I'm going to do instead of writing this, I write absolute value bars A minus lambda I instead of writing det, I write this, which you may be like, all right, that doesn't seem that fancy, but when I quickly write it out, I get just the 3, -1, 5, -3 with absolute value bars around it. And it's just a shorter notation. So let me do A minus lambda I. I'm going to do a minus lambda along the diagonals. So I get, oops, that's a +3. Come on. 3 minus lambda, -1. And then 5. And then -3 minus lambda. Remember, this is equal to 0. That is another way of saying this equation right here with this A matrix right there. So let's go ahead and solve this thing. That gives me 3 minus lambda. Remember, I'm going this product plus this product minus. So that gives me 3 minus lambda times -3 minus lambda. And then I get another double negative on this one, so I'm just going to get +5. And then that's equal to 0. So from there, I get a -9, and then -3 lambda. I get a +3 lambda, and then I get a plus lambda squared, plus 5 equals 0. This works out really nicely because these two cancel. The 9 and the 5 combine to give me a -4. So I get lambda squared minus 4 equals 0. From there, I'm just going to do difference of two squares. Lambda minus 2 times lambda plus 2 equals 0. And then now I'm at the spot, step number 2, where I am finding a solution to A minus lambda I times this A1, A2 equal to 0. So I'll put that right here. Paste. Missed a piece here. Solution. All right, so what am I going to do? Well, I'll take my first lambda, and we'll do blue. Lambda equal 2. And what I'm going to do is I've already written the A minus lambda I here, so I'm just going to take this work right here and subtract 2 along the diagonal, looking at this right there. So I get 3 minus 2, which is 1, and then a -1. And then I get 5, and then I get -3 minus 2, which takes me down to -5. And now, remember, I switch along the horizontal row. I switch and negate 1. So again, this is really nice. When I switch them, I just get 1, 1. And, this one would be, this one would be negative if I switch them. But the double negative, I make that one positive. So the eigenvalue of 2 has an eigenvector of 1, 1. Then I'll take my eigenvalue of -2, and again, just plug it into this right up here. And I've already got it written there, so I'm not going to rewrite it. I get 3 minus a -2, so that adds to give me 5 because a double negative, and then a -1, and then a 5 here, and then add 2 to -3. And I get a -1. And again, switch and negate. So the rows are exactly the same here. So when I negate and then switch, I get a 1 and a 5 here. And if I multiply across and down, and across and down, then they both zero out. Same thing here, across and down, they zero out. So all I got to do now is write my solution out. X equals C1 times 1, 1, that's this vector, times e to the lambda t, oops, e to the 2t, and then plus C2 times 1, 5 times e to the negative 2t. Now I will comment briefly about why it is like this. Well, A, it should match what you got when you did elimination on this thing. But B, if you remember back to when we were proving that this was true and we borrowed some things from linear algebra, our trial solution was A1, A2 times e to the lambda t. So the whole goal with all the work that we did, and that's not what this video is about, you should already have seen that, was to find the A1, the A2, and the lambdas that fit that. And what we found was we had these shortcuts, right? So we would do this DEET, that skipped a whole bunch of work, and then you have to find your lambdas, and then find the A1 and A2 that go along with it. So at this point, you should be able to practice some of these, and it may feel a little weird in terms of like, what do you do? But the more you do it, the better you get at it, and eventually they'll become second nature, and you'll start doing almost all of this work in your head. So thank you, and good luck. See ya. Peace.